General counting principle. This is an introductory lesson in preparation of lessons in probability and has little background material. It relies on simple multiplication, which ties conceptually to computing areas of rectangles. In this lesson, we will count the number of ways to make a selection with multiple parts. In a cafeteria, kids can be served a meal by choosing one of 5 main dishes, along with one of 4 sides. There will be hundreds of kids visiting today, and so we would like to prepare the meals in boxes ahead of their arrival so that we can be as efficient as possible serving them. How many different kinds of boxed meals will we need to prepare? We can think of this as a 2-step process. First, we prepare the main dish, then add the side. Each of the main dishes can be sent to one of 4 stations to add the appropriate side dish. It is easier to visualize the selections by listing the main dishes in rows and the sides in columns. Choosing a meal is now as simple as checking off one of the boxes in the grid. Since there are 5 rows and 4 columns, there are 5 times 4 equals 20 choices of meals. Now let's add the drink. The calculation is similar. There are 20 meals that can go with milk and 20 meals that can go with juice, so we have doubled our choices to 40. This 3-part process can be thought of as a 3-dimensional grid. The first page has the main dish rows and side dish columns with milk. The second page has the main dish rows and side dish columns with juice. On this 2-dimensional screen, it's harder to represent this 3-dimensional idea, but the principle is the same. Our total choices are 5 times 4 times 2 equals 40 total choices. We could add a 4th choice and the same principle would apply. Just multiply the choices at each stage. Here is the general counting principle. If there are m possible outcomes for a first event and independently n possible outcomes for a second event, then there are m times n possible pairs. Here's an example. A deck of cards has 4 suits. Each has 13 values, king, queen, jack, on down to ace. How many cards are there in a deck? To get the answer, multiply 4 times 13 to get 52 cards. Here's a visual of the deck of cards. There are 4 columns for the 4 suits and 13 rows for the 13 values. Here's a second example, rolling 2 6-sided dice. There are 6 choices for the red die and 6 for the blue die, so a total of 36. There are 6 rows for the 6 different values for the red die and 6 columns for the 6 values of the blue die. Here's a final example. In 1947, the United States and Canada adopted a telephone numbering plan as follows. The first 3 digits were the area code. The area code could not start with 0 or 1. 0 would dial the operator, and 1 was an indicator that you were calling somebody long distance. The second digit had to be a 0 or a 1 to distinguish them from exchanges. The exchanges could also not begin with 0 or 1, and their second digit could also not be 0 or 1. Otherwise, all of the digits 0 through 9 were allowed. How many phone numbers were possible? We need to multiply our 10 steps together. 8 possible first digits, 2 possible second digits, 10 possible third digits, 8 possible fourth digits, 8 possible fifth digits, 10 possible sixth digits, and 10 possibilities for each of the last 4 digits, for a total of 1,024,000,000 possibilities.